right, we are looking at your Unit 2 notes, and as we look at their Unit 2 notes, we're actually going to be focusing on predicting the charges of the ions. As we do that, I'm going to use the periodic table in order to help you learn their basic charges. So along this family, you might remember that those are in fact the noble gases. And the noble gases are not going to have any charge, so we're going to go ahead and we're going to call those a 0 for their oxidation number. Next to them are some additional nonmetals, and those would be the halogens. The halogens, you might remember, will be -1 in charge, and that's going to include your fluorine, your chlorine, your bromine, and your iodine. We're not going to worry about astatine at this time. Next to them, this family, including oxygen, sulfur, selenium, and tellurium, will all be -2. Next to them will be -3 with your nitrogen, your phosphorus, and your arsenic. And then you do also have carbon acting as a nonmetal and a negative ion, and it's going to be -4 and named carbide. You're going to see that I'm stopping right in here, and that's because there are a series of metalloids. The metalloids are going to have both metallic as well as non-metallic properties, and so they're sometimes going to behave as metals and they're sometimes going to behave as nonmetals. You can see the arsenic is going to behave as a nonmetal, as a -3, while the tellurium will also. But at the same time, the metalloids that are on their left-hand sides are going to actually behave more metallic. When you go and you name these ions, because they are metals, all of them will end with an IDE ending. So when you are talking about carbon as an ion, you're going to call it carbide. Nitrogen as an ion, you're going to call it nitride, etc. as you add the IDE ending, replacing the original ending that was there. The other element that we want to look at that's also going to be considered a nonmetal is, of course, going to be your hydrogen. Every once in a while, hydrogen is going to be a -1. You're going to cross it maybe once in your lifetime if you don't take chemistry in college. So say, for example, it was bonded with lithium. That hydrogen now, notice how it's the second element, would now be named lithium. And again, because it's now a nonmetal, it would be hydride. Again, you're not going to see those too often. So now let's look at the positive ions. Usually, hydrogen is going to act as if it's metallic, even though, again, it's a nonmetal, and it has a +1. When that happens, you will name it positive, with the +1 charge, you will name it hydrogen. Below that are your alkali metals, and again, your alkali metals are your group 1 metals. Since they are, in fact, group 1, you're going to have them all be +1. So that's going to include our lithium, that's going to include your sodium, your potassium, your rubidium, and your cesium. And again, all of those are going to be +1. Next to them are your alkaline earth metals. And your alkaline earth metals, since they are in group 2, will in fact be +2. That's your beryllium, your magnesium, calcium, strontium, and barium. At that point, you have nice monatomic ions. You also have ones that have the single oxidation number. So if we go back over to the far right, aluminum is going to be another one that's included as having a nice single oxidation state of +3. Zinc is another, has a lovely single oxidation state of +2, as does cadmium right below it, as does silver. Now notice that the zinc and the cadmium are both +2, aluminum is +3, and silver is +1. You have a number of other transition elements now that are going to have different oxidation states. If we take a look, and I'm going to use this area down here, again our alkali metals were +1 in group 1, alkaline earths +2 in group 2. If you actually head right on over to the right into those transition elements, what you're going to see is that your scandium, which is right there, is going to have a single oxidation number of +3. Same with yttrium, with a single oxidation number of +3. So if you notice the pattern, right, as we further go to the right, we have titanium commonly with a +4. We have zirconium again with a +4 as a really common oxidation state. We have +5 for vanadium, +5 for niobium, and then those are your most common. In the very center of your transition elements, what you're going to find are a series of elements that will actually have multiple oxidation states now. It actually turns out that it's going to be these 5 elements that end up doing it. And what they're going to do is rather clever. They're actually going to be +2 as well as +3. It's clever in the sense that if you take 2 and add it to 3, you come out with a 5, and there's only 5 elements that are doing it. That's your chromium, that's your manganese, your iron, your cobalt, and your nickel. Again, these are the most common oxidation numbers, not necessarily the ones that you are going to encounter only, but definitely the ones that you're going to encounter the most frequently. It's this area with the zinc and the silver that seems like they were doing such a good job being a single oxidation number that actually falls apart. Next to zinc is copper, and copper is going to come as a +1, and it's also going to come as a +2. Below silver is gold, and gold is going to come as a +1, but it's also going to come as a +3. So on the upside, this group, this family, which is termed your coin metals, are going to be all +1, but copper will also have a +2, and gold will also have a +3. Below cadmium is probably the most unusual element that there is, and that is because it's mercury with an Hg2 +2 and a mercury with an Hg +2. The top one is named mercury 1 because while there are 2 mercury atoms, each atom is carrying a +1 charge. So +1 plus +1 gives you a +2. The second one is named mercury 2 because the single mercury atom carries a +2 charge. What's then going to happen is you're going to look from, again, the alkali metals with our +1, our +2, and now if you skip all of the elements that are the transition elements and head to the same family as aluminum, what you're going to see is we're going to do 2 things. We've got our gallium, we've got our indium, and we have our thallium. What's going to happen is they're going to share that +3 that aluminum has. But if you notice, they're also starting this new block. And because they're starting this new block, they're also going to carry an oxidation number of 1, because they're the first group in this area of the periodic table. Next to gallium, will be germanium. And if you're getting the gist of how this goes, if aluminum was positive 3, germanium would be positive 4, along with tin as a positive 4, and lead as a positive 4. But at the same time, along with gallium, it's the second group in this area. So it's also going to be positive 2. All three of these elements will now be either plus 2 or plus 4. Next to tin is antimony. Notice it is Sb. And again, you're going to have a positive 5 as an option. Bismuth also with a positive 5. And then again, because it's the third group, in this new area, it's going to be positive 3 as its other option. So if you learn their locations and the general trends, the main area of concern actually ends up being where you see these elements that really have very little, if any, wasn't expecting that, which really have little, if any, pattern to them. You just have to kind of brute force memorize them. But the other ones have a really nice sort of synchronized pattern that is going to be easy to follow. Let me also at this point out some very simple ideas that you're going to want to know. And that's, for example, iron, right, has the prefix Fer. Cobalt is the prefix cobalt. Nickel is the prefix nickel. Copper is the prefix Cup. Gold has the prefix Or. Mercury has the prefix Mercure. And notice what's going to happen is, again, whatever is the higher oxidation, you're going to end up calling that a suffix of "ic." A lower oxidation would be a suffix of "us." So you can either name them by their charge and use a Roman numeral in parentheses, or you can go with a traditional name and use the higher oxidation state with an "ic." So ferric would be positive 3, ferrous would be positive 2, since positive 2 is the lower of them. Some ones that are harder that I do want you to know, as well as Mr. Seiler, would be your tin with a Latin root of stan, as well as your lead with a Latin root of plum. Some students have sat down and tried to remember that, so they basically just say Stan the plumber in this area in order to remember that it's stanic, stanos, and plumic and plumas.